Lesson 6.5 is going to talk about the quadratic formula and the discriminant, which is part of the quadratic formula. Your quadratic formula is something you've seen before, and it is this formula right here. It's a formula that will be given to you for testing, and both at the state and in our classrooms. But it's the opposite of b plus or minus, that's where we get our two answers, the square root of b squared minus 4ac all over 2a. And remember, that means we are starting with that standard form of that quadratic equation equals 0. This is still finding our solutions or our roots, or if it says solve. Okay, this is where we are crossing that x-axis to get those x-intercepts. All of those are synonyms. So, a couple of different things can happen. So if we are talking about two rational roots, so it's possible, just like when we saw when we were solving, that we could get two rational roots. So number one, we always have to have our equation equal to 0, just like when we are factoring, just like when we're doing any of these things. So the first thing I'm going to do is subtract 33 from both sides. So I have x squared minus 8x minus 33 is equal to 0. Now if I wanted to go ahead and try to factor this, I could. It may or may not factor. Quadratic formula always works. Now, we learned that factoring doesn't always work. We can make completing the square factoring always work, but it takes some work. It takes several steps. Quadratic formula always works, but there are several steps to it. So once I have this in standard form, I know that a is 1. Just remember there's a 1 right here that I don't write. Notice standard form is pluses, so this is really plus negative 8 and plus negative 33. So b is negative 8 and c is negative 33. So I just go ahead and plug everything into my formula. So the opposite of b, notice that if it's negative, I'm doing the opposite of. So I'm going to end up with a positive plus the square root of b squared minus 4 times a times c. Be very careful with your negatives and your signs. And that is all over 2 times a. Make sure when you do this fraction bar that you get everything. Temptation is to forget that part. There's always an addition or subtraction right here depending on your signs. Don't magically turn it all into multiplication. A lot of times I will change this to plus minus 4. So what happens when I work this out is I have 8 plus or minus the square root of all of that becomes 196. I don't recommend doing this all at once in your calculators. I would do this stuff under the radical first. I would hit equal and write it down. Please remember, when you square a negative, it will always be positive. Don't over trust your calculator. And what happens at this point is 196 is a perfect square. So I have 8 plus or minus 14 all over 2. And what I like to do at that point is split my problem. I have 8 plus 14 all over 2, or I have 8 minus 14 all over 2. So this is 22 over 2, which is 11. There's my first solution. Here I have negative 6 over 2, which is negative 3. There's my second solution. When you get nice whole numbers like this, it means it would have factored. But this is your example of two rational real roots. Now, what can also happen is we can end up with one root. So remember, in your picture, that means that something, open up or open down, like that, is going on. So I check, I'm equal to 0, so I'm good to go. A is 1, B is negative 34, C is 289. So to my formula, the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. What happens when you work that out is I get positive 4 plus or minus square root of, when you take negative 34 squared and you subtract 4 times 1 times 289, you get 0. Oops. That should have been a 1 there. All over 2, which is 34 over 2, because the square root of 0 is 0, which is 17. So we have some sort of open up parabola with that touches vertex, as we know. It's going to touch somewhere out here at 17. So just one solution. Now, sometimes we can get irrational roots. Now remember, irrational numbers are non-repeating decimals. A lot of times are square roots. So when I go to apply the quadratic formula here, I've got it equal to 0, so I'm good. A is 1, B is negative 6. If you're having trouble seeing it or remembering, go ahead and do that. C is 2. So I have the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times A times C all over 2 times A. The opposite of negative 6 is positive 6 plus or minus the square root of 36 minus 8. I end up with 28 here, all over 2. Now, 28 isn't a perfect square, but it is equal to 4 times 7. And so I have 6 plus or minus the square root of 4 is 2. 7 is my leftover. That's review from last chapter. All over 2. But math grammar, I see that all three of those numbers have a common factor of 2. So I'm going to factor that out by dividing greatest common factor. Now why do I do this? Remember, we can never cancel next to addition or subtraction, so I need to turn this into a multiplication problem. 2 divided by 2 is 1, and my answer is 3 plus or minus the square root of 7. That's two answers, 3 plus the square root of 7 and 3 minus the square root of 7. This is exact, and this is how we want to leave it. So you never need to go to your calculator. Now, again, pulling in ideas from last unit, we can end up with some sort of complex number, something with a real portion and an imaginary portion. This is not equal to 0, so I need to subtract 6x from both sides. And so I have x squared minus 6x plus 13 equals 0. Notice I put it in descending order of my variable. When I start with my quadratic formula, I have the opposite of negative 6 plus or minus the square root of negative 6 squared minus 4 times A times C all over 2 times A. When I work this out, I end up with 6 plus or minus the square root of negative 16 all over 2. Now if you need to think about negative 16 as negative 1 times 16, I have 6 plus or minus the square root of 16 is 4. The square root of negative 1 is I. That's all over 2. Again, we check for greatest common factors between all three pieces. There is one. So I'm going to go ahead and say 2 times 3 plus or minus 2i. Factor that out. All over 2. Now I have a multiplication problem. I can cancel, and my two answers are 3 plus 2i or 3 minus 2i. It would also be okay if you want to write it as 3 plus or minus 2i. So I have both of my answers represented there. This is a preview. We're going to come back to this. So wouldn't it be nice if we could figure out how many answers and what type before we even start? Are they going to be rational? Are they going to be irrational? Are they going to be complex? Is there one? Is there two? Is there none? What's going on? Well, there's a little way to cheat, and that is by looking at this piece right here, which is called the discriminant. Just the portion under the radical sign tells you how many answers you'll have and what type of answers you'll have. So if we look just at that, so we have the opposite of b, habit. If we look at just the discriminant, which is b squared minus 4 times a times c, this is going to be 36 minus 36. So we really end up with the square root of 0, which means that we are going to have one real rational solution. If we look at this example and we do 3 squared minus 4 times 1 times 5, again, just looking at that discriminant value with my a, my b, and my c, this ends up being the square root of negative 11. That obviously is going to give me an imaginary number. This means I'm going to have two complex solutions when I'm all said and done. So before I even start, I know what I'm looking for. That's that discriminant value again. If I look at this one, I'd have 8 squared minus 4 times a times c, which is negative 4. So I'm going to have 64 plus 16, the square root of 80. Now, the square root of 80 is not a perfect square, and so I'm going to be left with some sort of radical, which means that I'm going to have two irrational solutions. And what happens over here if I take negative 11 squared minus 4 times a times c, I end up with the square root of 81 under my radical. That's a perfect square. And so that means I'm going to have plus or minus 9 in that last of that fraction. And this means I'm going to have two rational solutions, like the very first example. So if we go back to the summary table, the discriminant, if it is positive, greater than 0, and a perfect square, two real rational roots. If it is positive, not a perfect square, two real irrational. If it equals 0, one real rational. If it is negative, two complex roots. And this last table is a summary of the whole course.